Hi everybody, this is Mr. Nolan, and what we want to be able to do today is to be able to trace and explain the movement of energy through an ecosystem. So in previous videos we focused more on the movement of carbon and biomass through an ecosystem, but today we're sort of going to look at a related concept but a little bit different, and that's the movement of energy through an ecosystem. So that's what we want to be able to do today, is to be able to trace and explain the movement of energy through an ecosystem. So to do that, I have a nifty little diagram here that we can look at in order to sort of make sense of this. So what we saw in the previous video was this one, where we saw this ecosystem and we looked at the movement of all the carbon through this ecosystem. But today what we're going to look at is this diagram. This diagram is a little bit different. It's a little bit more sort of technical looking rather than sort of pretty pictures. And so what we're going to use for this diagram is to show how does energy move through an ecosystem with this diagram. So we're going to use arrows, but just again keep in mind that today we are talking about energy. So that's what we're going to talk about. So the first thing that we should make clear is, where does this energy come from in the ecosystem? What is the ultimate source of energy? And what we should recognize that the ultimate source of energy is the sun. So this is really our ultimate source of energy, is the sun. The sun produces light energy. This is actually used by our other organisms in this ecosystem. So we've got our sun here. This is the ultimate source of energy. And the way that that energy enters the ecosystem, it doesn't enter by the herbivores, it doesn't enter by the carnivores or the decomposers, because we can't really use the sun's energy directly. It's nice, it feels nice, but we really can't use the sun's energy directly. But producers can. They actually take that sunlight energy and they perform photosynthesis. So photo, and that's in the form of light energy. So they actually are able to take that light energy and use photosynthesis to produce chemical energy. So the producers, like plants, are able to actually produce chemical energy from something like light from the sun. So this is where the energy first shows up. It comes in from the sun. So now we have this issue of trying to figure out, well, where does the chemical energy from the plants go to? So let's figure out all the different ways that the energy that is now made in the plants and chemical energy, where can that chemical energy go? Well, the most obvious answer is that the chemical energy can show up in the herbivores through eating. The herbivores can eat that chemical energy, and it is still chemical energy. It remains chemical energy. It's not like it's anything else. When that food energy, that chemical energy, shows up in the herbivores, it is still chemical energy. Now, those herbivores can in turn be eaten by some other things. They can be eaten by carnivores. Again, they can be eaten, and that still is chemical energy that shows up in the carnivores. So we have this movement of energy up through these different levels of the ecosystem, from our plants up into the herbivores and then up into the carnivores. So that's chemical energy moving up from the producers, herbivores, to carnivores. So this is sort of the most obvious movement of energy in our ecosystem. But there's a lot of other ways. We're only just barely started in putting this system together. So where else can those producers put their energy? Well, they can die. And if they die, then that means that that energy is going to show up in the soil as the decomposers eat it. So the plant can suffer from death, can die, and that chemical energy can show up in the soil. Right? And those decomposers can now eat that plant matter and sort of get decomposed, so that food energy now shows up in the decomposers. But plants are not the only organisms that can die and be decomposed. Herbivores can do that too. So this is going to get a little bit crowded, but herbivores can also die. So you have death, and that chemical energy is going into the decomposers when those bunnies die. And when we say death, just to be clear here, death or defecation, we're talking about the bunnies are not dying by being eaten. Because if they're dying by being eaten, that means their energy is going into the carnivores. But in order for their energy to show up in the decomposers, they're going to basically die of natural causes instead of getting eaten. They're going to die of a disease, or just die of old age, or maybe fall off a cliff, or something like that. And so when they die, they're going to be decomposed. So predators are also not immune from death. Predators can also die, and their chemical energy can show up in the decomposers. So everybody can die. All of our different organisms can die and show up in the decomposers. So that's one other way that our energy can move through our ecosystem, is that the food energy in these organisms over here can show up in the decomposers when they die. This even happens to people, believe it or not. When a person dies, no matter how they die, their chemical energy is ultimately returned to decomposers. And so we're going to look at now, where does it go from there? So there's a process that we haven't talked about yet as far as where our energy can now go. Let's say that we have chemical energy in our carnivores. We have chemical energy inside our decomposers. We've got chemical energy all over the place. Where else can this chemical energy go besides getting eaten? Well, when you and I move around and live in our daily lives, we are constantly losing energy in the form of heat. And we're also using some of the chemical energy that's in our body in order to move around, so kinetic energy. So we're always losing energy in the form of heat. So if you're a bunny rabbit, you're going to lose energy in the form of heat. So we're going to lose heat energy. And the way that we lose that is through the process of cellular respiration. So I'm going to sort of abbreviate that with cell, R-E-S-P. Cell respiration. Heat can escape those herbivores. It can also escape from the carnivores in cell respiration as heat. And believe it or not, even decomposers and plants can actually lose that energy of heat through cellular respiration. So plants do produce a little bit of heat by cellular respiration. We can't really measure it. It's too small to be able to measure. But believe it or not, plants really do emit a little bit of heat. They have to, because in order to move and function, some of that energy is lost as heat. And so from every living thing that does cellular respiration, we are going to be constantly losing heat in that process. One thing I do want to clarify is that when these organisms lose their energy as heat, it might be tempting to point that heat at the sun and say, oh, well, the energy is going back into the sun, and then the cycle starts all over again. But if you think about this logically, there's no way in the whole wide world that the heat that exists on the surface of the Earth can ever show up in the sun. The sun is 93 million some miles away. There's no way that the heat from the Earth is going to show up in the sun. All of our energy comes from the sun. The sun doesn't receive any energy. So there's this mistaken idea that there's something called an energy cycle, where we have energy, and then it's transformed into some other kind of energy, and then it's transformed back into energy. This does not exist. There is no such thing as an energy cycle. Once this energy over here is lost as heat, right? So when the plants or the decomposers or the herbivores or the carnivores, when they lose that energy as heat, it is gone forever and ever. It goes out into outer space, and it will never be used by any other organism again for all eternity. Once energy is lost as heat, it is done. It is gone. Its story is over. It is not going to be involved in an organism or any other kind of useful application for the rest of the universe. So, just to be clear, there is no such thing as an energy cycle. The energy that's lost is never reused. It's a one-way situation. It comes in from the sun, it goes up through our ecosystem, it moves around through our ecosystem, and then it's gone. As soon as cellular respiration happens, it is out of here. So we don't get this energy back. It's gone. So I just hope that that's sort of illuminating as far as how does this cycle work. It's not a cycle. How does the movement of energy through an ecosystem work? So I hope that at this point, now that we've talked about that, you are able to trace and explain the movement of energy through an ecosystem.